Welcome and thank you for joining us for another episode of the Jane Irrigation Training Series. I'm your host, Richard Restucia, and today we're going to be talking about what is a little bit of water awareness, what's happening in California, what happens to California water, and maybe a lot about some experience as well as some opportunities to improve. And why I think this is so important is oftentimes we see what happens in California on regulation or on laws tends to move east across the country. So it's always interesting to take a look at what California is doing with water and see if maybe that's a potential outcome for other states. Now, taking us through this journey of water regulation and water improvement, water conservation improvement is Jim Loria. He's the Vice President of Sales and Marketing for Maisie Injector Company. But Jim is so much more than that title. I'm sure you have seen him around on LinkedIn. He writes about water in a very interesting and different fashion. I hope you've listened to some of his podcasts because Jim is out there and he is making water interesting. And that's something that's frankly quite hard to do. So anyway, I'm always anxious to get together with Jim and hear what he has to say about water and water conservation and who's doing what and how they're doing it. It's always interesting. So Jim, welcome and thanks for joining us today.
Thanks, Richard. It's always a pleasure. I always enjoy these webinars that you put on, and I'm really excited about making this presentation today.
Yeah, well, so are we now. But the first thing I got to ask you right off the bat is, isn't it a canary in the coal mine, not canary in the gold mine? I don't understand.
Yeah, so a friend of mine said this by mistake. It's known as a malaprop, and we talked about that. It's basically using a similar sounding word in the wrong context. And what I thought about was when I heard it about California and the fact that while we have many challenges around water, there's many opportunities in a wide range of market sectors and technologies. So I first came up with the idea back around the time of the IA, and you and I had dinner together, and I told you I was going to write a blog post about it. And when I told you that, you said, Jim, we got to have you on the show to talk about it. So here I am.
Yeah, and that's great too. And we're very interested in getting into that. Yeah, I wasn't sure about this canary in the gold mine. I thought it had something to do with a Gatlin Brothers song or something, but not the case.
Yeah, not at all, not at all. So, you know, California is the golden state, and there's a lot of reasons for it. Sunshine, but mostly because of the gold rush of the 1800s. And you had Mark Arix on a little while back, and he wrote The Dreamt Land, and he told some of the stories about some of the water follies that California went through. One of them was actually sluicing whole mountains away, trying to search for gold. And so I wanted to bring that up. I mean, like I said, there's a lot of challenges, but there's a lot of opportunities here in California. And if we can get it right, in some of these areas, then maybe some of the other places throughout the world can learn from us and adopt some of our technologies, some of our management practices, and become the benchmark of what other people are doing. So I want to start with the circular water economy. And as I've talked about in a number of venues, the circular water economy begins and ends with agriculture. And as most of us know, and been presented around for a long time, about 70% of the water that we humans use is used for irrigation to grow food, fiber, and fuel. But that water that's being used and the fertilizer nutrients that go along with it, they don't only go to the crops, but they also run off, right? They run off into groundwater, they run off into surface water. And that can be problematic because that becomes the source water for a lot of the other applications we have. Residential use, industrial use, the other 30%, 20% typically to industry, 10% for residential. And so we've got drinking water, commercial water, and that runoff that becomes the source water that can contaminate some of the other sources of supply. And then after you complete those, you've got municipal sewage that can be recycled and reused. You've got water coming from food and beverage processes that could be recycled and reused. Oil and gas, produced water, which cleaning it up, removing the contaminants can be reused. And so if that's going to be reused, where is most of that water going to end up going? Well, it's going to go to the 70% that's required for irrigation. And the good news is you don't have to clean it up as much if you're not using it for drinking water. You're going to use it for irrigation, which could have some good nutrients and fertilizer already in it if you've got the right constituents in the water.
So Jim, I have a question about that. A couple
Sure.
of questions now.
Sure.
One, what percentage of the irrigation water is being used for agriculture? You know, how do you break that down?
Yeah, so I would consider it for all agriculture. I mean, for landscape, we talked about this before, Richard. For landscape, I'd say you're looking at that as more residential, because really that's coming from, you know, the city water that for in urban and suburban areas, right? So most of that irrigation water is for agriculture, growing food, fiber, and fuel.
Yeah, so I think there's, I only mention that, right, because I think there's a lot of people, and I'm all for conservation and landscape and in the cities, right? That's been my job for 20 plus years, but that alone isn't going to solve the problem. We've got other big users that have to help contribute, right?
Right. And you know, I usually say that a household is kind of a microcosm of the whole picture, right? So probably if you've got a lawn and you're watering your trees, your lawn, your flowers, whatever, that's probably 70% of the water that you would use. 10% would be for drinking, and then the 20% would be for cooking, showering, all the other things. Just kind of rough numbers, right? Nothing exact.
Yeah, and then I'm always surprised at how many people, probably nobody on this webinar, but how many people out there don't understand that all the water that's ever been is all the water we have now. I mean, it's a closed loop system, and we're always just reusing the same water. Exactly. And I don't think I don't think there's a lot of public awareness of that. I think nobody figures that out, and without coming to a webinar or something to learn it. It just doesn't come naturally to people. Right.
And then something I presented a while back on one of your webinars was this whole idea about the connection between water and ag and carbon neutrality. And the Lawrence Livermore Lab a while back put this report together, about a 200-page report on how to get to neutral, and none of it really considered agriculture. They talked about things like cover crops and pyrolysis and creating biochar, and actually putting equipment out there that would pull the carbon dioxide right out of the atmosphere. And to me, I was like, well, if you're going to do that, that's going to require some water, right? So why not give the water to the farmers? And so I wrote this op-ed piece back in last April, and I've been speaking about it ever since. And I really feel that it's an important part, because really there's a lot of opportunity around that. And so I talk about ag tech. Ag tech is defined as any innovation in agriculture aiming to improve yield, efficiency, profitability, or sustainability. And people think of ag tech as drones, as satellite imaging, as robotic tractors. But for me, it's really smart irrigation. That's really where the rubber meets the road, where the water actually, and nutrients and fertilizer that comes along with it, actually get to the plant. And that can be a good source for conservation. It can also be a good source, and we'll talk more about that, for carbon capture and reduction of greenhouse emissions. So, smart irrigation, precision agriculture equals distribution uniformity. And it's not only in terms of distribution uniformity, again, for the water, but it's also the nutrients and fertilizer. And I just read an article about how, if you're looking at the ability of soil to capture carbon, one of the biggest parameters is the moisture. It's moisture, not the temperature, not anything else. It's that moisture that allows the organic content to be captured. And that's an important aspect of not only of good crop growth, but also good management of carbon and the other greenhouse gases.
Yeah, it's a really good point, Jim, and a very simple concept, right? This distribution uniformity. We see how much it can be improved with drip irrigation, for example.
Exactly. And there's been some studies done on drip irrigation, all those things, yield improvement, reduction of greenhouse gas emissions, and obviously saving water, right? So there's a lot of aspects of, besides just saving water, improving crop per drop, that really is enhanced by drip irrigation. So when we're talking about, again, this goes back to the source water, we've heard about blue baby syndrome, of the nitrates getting into the groundwater. And the idea is that, again, if you protect the source water, then you don't have to treat that source water later on down the line. And you're talking about, when you talk about water treatment, you're talking about chemicals, you're talking about energy, you're talking about infrastructure. So, in that regard, protecting groundwater is really important. And then protecting surface water. So we all heard about the algal bloom in Lake Erie that almost shut down the Toledo drinking water plant. And they were threatened with cyanotoxins. And Maisie was involved in that plant very extensively. We provided a lot of the ozone equipment, and that's a rendering of what the plant looks like to remove these cyanotoxins from the drinking water plant. And what you see here is a lot of concrete. And concrete, I mean, that's one of the biggest sources when making cement, one of the biggest sources of carbon release, and then steel. And that's the other big place where you're talking about greenhouse gas emissions. And not only that, you're talking about chemicals, you're talking about energy. And so, by doing what's right in the agricultural arena, you're doing a lot better job in saving these kind of things downstream, right? It's all downstream.
Yeah, so I think what you're saying, correct me if I'm wrong, but I think what you're saying is the cleaner we keep the water, the easier it is to clean up.
Exactly.
And the less expense there is to do that. Exactly.
So yeah, and less effort and less money and less greenhouse gas emissions, right? So the other thing about greenhouse gases, we talked about carbon dioxide, which is by far the largest contributor to greenhouse gas emissions, but nitrogen's pretty potent gas. And so you've got the nitrogen inputs to grow. You need that to improve the efficiency of growing, the yields, but not all of it stays in the plant, right? So some of it leaches out, as we talked about, into the groundwater. And then a lot of it also is released as gas via ammonia, nitrous oxide, nitric oxide, nitrogen gas. So this can be pretty problematic because it's about 300 times more potent as carbon dioxide as a greenhouse gas. And this is a pretty stunning look at what is really contributed as far as nitrous oxide from agricultural soil management. I mean, 3/4 of it is responsible, and then small amounts from wastewater treatment, combustion of in creating power and chemical production and so on. But you can see what a big amount agricultural soil management contributes to nitrous oxide emissions.
Yeah, what's striking to me about this pie chart is that not so much that ag soil management is 74%, it's just the distance between 74% and 6%. Yeah, it is. Oh, wow. I thought wastewater treatment might be higher on that scale or something else. It's that's what's really shocking to me.
Yeah, absolutely. So there is some effort on the use of oxygenation to really reduce the amount of nitrogen emissions. And going back to the 40s, W.D. Durrell said if we could figure out a way to efficiently oxygenate the root zones, we could really do a good job of helping with reducing that nitrogen emissions. So there's a couple of different ways to do it. Ventilation using a compressor, but that's difficult. If you're doing it dry, I mean, you don't get the distribution of the air, and it can be problematic to have a compressor out there. Chemicals, you can use hydrogen peroxide, but it's a strong oxidizing agent. And so for two reasons, handling it can be a little dangerous for laborers putting it into the system. But also, if you put too much in, you can end up killing some of the beneficial microbes, the bacteria that really helps with the uptake of the fertilizer nutrients. There's nanobubbles generating systems. We've heard about them most recently. They do a really good job of getting those small nanobubbles into water. More suitable probably for indoor vertical farms. The equipment can be a little expensive, and also maintenance. I mean, if you've got them out in the field, they can be a little challenging to maintain. And then what Maisie promotes is adjection. We've done a lot of work on the yield increases, reduced less NOx. What we found is that by having good aerobic activity in the soil next to the root zone, you're doing two things. Number one, with the bubbles, you're breaking up the soil. So we call it plowing without a plow, but you also improve the dissolved oxygen. That helps the aerobic activity in the soil, better uptake. And also we found that it helps the nitrogen fixing bacteria become more efficient. And it's been proven out that you're getting less nitrous oxide and some of the other nitrogen gases released using this. And just a little picture of basically how that's working. Chemical-free, no moving parts, and minimal energy and maintenance.
So Jim, if I look at that slide just a little bit longer, sorry.
Yeah. Yeah, go ahead.
So I'm getting air injection or air ejection in my irrigation just by using my Maisie fertilizer injector?
No. It's a specially designed Venturi. So you want about a 10% slurry of air in there. And so we design it around each flow rate compared to what you would have on using a fertilizer. So a completely different way of doing it. We're typically doing it through manifolds to be more efficient. So yeah, good question. It works the same way, right? Same, you're using a motive force of water to pull in the fertilizer case, liquid fertilizer. But when you're using air, it's a different interface, right? So with fertilizer, it's liquid to liquid transfer. With air, it's gas to liquid. So a different technology, same technology, but a different way of doing it.
And I can have both set up on my system. Is that correct?
Oh yeah. But you'd want to look at it. You got to look at them differently, though. Yeah. I mean, you would use fertilizer injectors exactly to pull in fertilizer instead of pumping it against pressure. So good advantages there.
Great, thank you.
Yeah, and then the other area that has an opportunity is indoor farms. We talked a little bit about that. Crops that can be grown inside, will be at some point. When we're looking at more tomatoes being grown indoors, green leafy vegetables. We're looking at strawberries, and then one of the biggest cash crops of California is cannabis, and more of that's being grown indoors as well. So, in order to properly manage the water, because you want to recycle every drop of water that's going in, so there's some opportunities around designing systems like this where you've got filtration, you've got ozone. You want to definitely protect the root zones from any pathogens. And if you don't manage this water and treat it properly, you build up biofilm, which is a place that really harbors pathogens that can be really detrimental to the crops that you're trying to grow indoors.
Yeah, so interesting, right? So they're capturing the extra water, any runoff from the plants, and feeding it back into their nutrient mix tank.
Right, exactly. And you're treating with ozone for sanitizing to kill those pathogens, filtration to take out any of the big particles. So this is a design by H2O Engineering. They're one of our partners. They use our equipment in the design of their systems.
Yeah, well, you can certainly see a lot of advantages for that.
Yeah, exactly. And then, while the vineyards are an important part of the water as an ag in California, there's been some pretty stringent requirements by the state water resources about the runoff and about the wastewater coming out of the wineries. And so they're putting more pressure on them. And so we've got some applications where we use our Venturis to pull in air and our nozzles to do some mixing in these wastewater lagoons, again, to help the aerobic activity so that you have better digestion of the wastes. And if you don't, and it turns septic and it becomes anaerobic, you're releasing methane. So in terms of recycling that water and also to reduce greenhouse gases, you really want to keep those lagoons aerobic. And as one of the ways we can do it is with some of these injectors. And we do a lot of work around CFD modeling, computational fluid dynamic modeling, so we can make sure that the lagoons are properly mixed, that they're getting as much air in all the different areas as possible, not completely mixed, but in such a way that you've got most of the lagoon aerobically treated so that you're doing the best digestion of these organic wastes as possible.
Yeah, pretty interesting. Definitely in that high-tech area, right?
Yeah. And we'll talk a lot more about that, the use of high-tech tools to manage some of the more simple aspects of water treatment. Now, this is one of my favorite projects that Maisie's been involved with, Pure Water Monterey, a groundwater replenishment project. And basically, this facility, they wanted to, because they're on the Pacific Ocean, and this is going to be a kind of a theme that we talk about going forward, is that as they're pulling more water up out of the ground, and Monterey is unique because you've got, residential people living there, a nice place to live. A lot of tourists come in during the summer. It's an agricultural community. So they're pulling water out of the aquifer. And what's happening as you're pulling water out of an aquifer, you've got, because you're close to the Pacific Ocean, the coastline, you're getting saltwater intrusion into that aquifer as you're pulling more water out. So this Pure Water Monterey, what they wanted to do was take a number of different wastewaters and treat them and then put them back into the aquifer to keep some of this intrusion out, and also use this water for other applications, use it as source water for their drinking water. And it was a tricky situation because they wanted to treat a number of different waters. They wanted to treat irrigation runoff. They wanted to treat municipal sewage. They wanted to treat water coming from a vegetable processing facility. They wanted to treat stormwater. I mean, now look, we've got these atmospheric rivers, and we're saying, well, it's great, we've got a lot of water, but now with the reservoirs full, a lot of that water is being wasted going out into the ocean. So if we could capture it and figure out where to put it. So that's what they did here. And you can see this is the type of system that they had to put in, pretty intricate, going from with ozone treatment, which Maisie was very heavily involved in, to membranes, to reverse osmosis, because they were looking at using it as a source of drinking water at some point in the future. They needed to do disinfection using UV and hydrogen peroxide, advanced oxidation process. So many different types of treatments. And the other tricky part was, as I said, because it's a lot of different types of water, when you've got the tourists heavy in the summer, you've got higher flows in the summer of municipal sewage, but then it rains in the winter. So you got more stormwater, and then the growing seasons, throw that into it. So we had to do some real playing around with the design. So number one, we could move the flow rates up and down, and also the different types of contaminants they would see based on these different types of ways. So pretty tricky. And again, using computational fluid dynamics modeling, it worked well. And we're even looking at how we can go to the next phase, because there's always the next phase, right? There's always a reason to go further.
Right. So this is pretty interesting. And one thing I'm learning, this is Pure Water Monterey. We had Michael Derwenko on about a month ago. He was talking about Pure Water Tampa. There's a Pure Water San Diego. This is really this whole concept of recycling the wastewater and making it drinkable, right? This is what we're doing.
Right.
Number one, how hard is that to do? Do we really get it that clean that we can drink it?
Well, if you go back to the previous slide, that's a pretty intricate process. I mean, you go in ozone treatment, then you go in membrane filtration, then you go in reverse osmosis, and then you go into advanced oxidation. I mean, that's a lot of steps in the process. So yeah, I mean, and people have the yuck factor, right? Now this isn't a direct potable drinking water. This is going down and then brought back up. So, some people feel like, well, I put that extra barrier in and I've got a little more safety. So, but yeah, I mean, it's a pretty intricate process, pretty advanced.
Yeah, and I just want to remind everybody that the reason I asked Jim this is he is a chemical engineer. And he really does know this. And more I'm seeing places like, Las Vegas or Phoenix, Arizona, where 90% of the wastewater is treated and used for ag or for drinking water. And their water rates are really cheap, right? So inexpensive, right? $40 versus a month for a family of four versus $200 for a family of four in California. Is really, I think, is going to be part of the longer term solution to our water challenges.
Right. And so as the first potable water reuse project in Northern California, as I said, it goes down into the seaside groundwater basin, turns wastewater into safe, dependable, and sustainable water supply. And it's about 30 million gallons a day. I mean, pretty substantial amount of water that's being treated. And this is the equipment that was delivered by us to do that part of the ozonation process, upstream of the membranes. So.
Yeah, what a beautiful job there. Wow.
Yeah, and then there's an expansion project to increase production and injection capacity. So we're already working on phase 2. So they're already trying to increase the amount of water that they can process, which is all good stuff. And then there's Orange County. This is the largest water recycling plant. It's won all kinds of awards. It's been around for quite a long time. I think presently now it's about 130 million gallons a day. And basically they're taking the wastewater that's being the municipal wastewater that's being produced in Orange County. They probably make about, let's see, maybe 350 million gallons a day. And of that 350 million, they take about 130 million and process it here to put it in the aquifer. The other one is they process it well enough that it goes out into the Pacific Ocean. So they're trying to look at how they can do more of what they're doing with the replenishment. Again, it's pretty sophisticated process, membranes, reverse osmosis, advanced oxidation to make it as clean as possible so that when they bring it back up, they can turn it into fresh drinking water. So it's just suitable for that.
Yeah, they're touting a number of almost 30% now, which is pretty great. Now, I love your made in the USA.
What's that?
That's really good.
What's that?
The made in the USA flag down here on the mountain.
Yeah, well, made in California, right?
Right.
Homegrown. So now we talk. You brought this up, San Diego Pure. It's a project we're involved with. Again, now this is more around toilet to tap, right? And we talk about the yuck factor, and we talked about the ability to turn it into safe drinking water. But people think, oh, it's coming from the toilet, it's waste, poopy water, they call it, poop water. It's all these things. But one of the things we can talk about is, and one of the things I've done in my, so right now it's doing about 34 million gallons a day, potable drinking water. We're looking at phase 2 to do 53 million gallons more. But one of the things I always like to look at is benchmarking what other people around the world are doing. And so the people in Singapore have been doing some really good work around this. And it's as much about the technology, it's as much about the communication to the general public as it is about the technology capable of doing this. And so they've had all kinds of outreach. They brought children from schools through the facility so that they grow up knowing, hey, the water's coming and being recycled, but it's clean to drink. They've got their own tap water that they bottle, and I forget what the name of it, but they branded it as, this water that's been treated. So it's an education process as much as it is and communication process as much as it is as understanding the technology that is capable of doing this kind of treatment.
Yes, we have got a question coming in from one of our viewers, and the question is this: do you see recycling or desalination as the primary direction in the future?
Well, I love that question, right? So it's a good tee up for the next one, right? So we got Carlsbad that's just up the block from you, right, Richard?
Right.
And they're doing 50 million gallons of drinking water daily. So what the thing about, and you and I know this, but I'm gonna full disclosure, I've written and talked about desalination for many years. And so on one blog post, I wrote about it, my views of desalination, and somebody from the political left said I was a anti-green, pro-business hack, was only writing stuff to make money for my company. And then somebody on the political right said I was an uninformed environmentalist who really knew nothing about desalination. So I think I've got a pretty nuanced view of desal. And number one, if you think about ocean water, it's got a lot of salt. It's got like 25, 30, 35,000 parts per million of salt, which is an ionic particle, which is one of the smallest particles you need to remove. So you've got a couple of ways of doing it. Thermal desal doesn't make sense for us, but reverse osmosis, pushing it through a membrane, does. But it's energy intensive. And then when you finish pushing that through and getting the fresh water, you've got brine that's like 200, 300 parts per million of salt. You can't just dump that right back into the ocean where you got it from. It'll kill all the marine life. So you've got the energy issue and you've got the brine issue. And there's ways to mitigate it. The membranes are getting much more competitive, much more efficient. And so there's some good things on the horizon there. And the brine can be mitigated. The Israelis are doing a good job on figuring out co-locating these desal plants near power plants where they can blend the water and the cooling water. I mean, it's things you can do, but if you say you can't say that this is the only way to go. And honestly, when you look at the processes that I showed for the municipal wastewater treatment, it's a lot less energy intensive and a lot less chemical intensive and equipment intensive than desalination. So desalination has to be part of the solution, but you can't lean heavily on it. And we have to have all those different, we have to have water reuse, water recycling of the wastewater and desalination.
Yeah. Yeah. So, right. It's going to be several solutions, not one solution, but right now the treated wastewater looks like a very efficient way to do this.
And look, I mean, you see this, you've got only 50 million gallons a day that you're looking at through Carlsbad. And the other ones are already surpassing that. And Carlsbad's been around for longer. And the other thing I want to say about desalination is this. as we have droughts, we're looking at every possible way to make fresh water, to get fresh water. And as I said, desal is one of them. But we got to learn from Australia. What happened in Australia was they built, because they were in a drought, they built these desalination plants, hundreds of millions of dollars. And then all of a sudden it started raining. And everybody was up in arms about the fact that we spent this money and now we don't need to use it because, hey, we've got the rain just filled the reservoirs. Well, someone said that's like buying fire insurance for your house and complaining that it didn't burn down, right? So I mean, it's an insurance policy against drought. And if we build it and we don't have to use it, well, we should say, well, that's good news, right?
Yeah, what a great analogy. I love that. So we've got another question coming in, and this person's asking about the, right, we know recycled water, we get clean water to drink. What about the solids or the biosolids that come out? Can we use those for fertilization and agriculture? What can we do with that?
Yeah, in some cases we can. I mean, you got to be careful because if you're concentrating everything, you know, you're going to have some contaminants in there that you don't want in the soil. So it's really, you have to manage it, right? You have to make sure that whatever you're going to put on the soil is not going to be contaminated. So yeah, so you know, I showed those processes. So some of those processes can take like the upfront filtration, where you're taking out a lot of the organic matter and things that can be used. But as you go further down, you want to make sure you keep the contaminants that could be problematic into the soil. You got to be really careful about that. So yeah, it's got to be managed, right?
Yeah. Okay, great. Thank you.
So this is another project that is interesting because it kind of skirts the line between municipal and industry. So East Bay Mud, it's up here in the North Bay area outside of San Francisco. If you ever drive over the Bay Bridge, you'll see it under there. And they do a lot of processing of all the wastewater in the San Francisco area. And what they did is a number of years ago, they worked out a deal with the Chevron Richmond refinery to take their wastewater, treat it to a certain level, and then send it over to the refinery to use it as cooling water. Ah. And the refinery has to do some treatment as well, some reverse osmosis, some membrane treatment. And over the course of time, they've been using that water for cooling, the landscape irrigation. That was in the 70s, 96, they did the cooling towers. And then in 2010, I was involved in this project with another company to use it for, again, boilers are a lot more sensitive than cooling towers. So you have to be really careful about what you put through those. And then, you know, again, using it for irrigation and industrial purposes. And then, you know, they're looking to expand that wherever they can. So a good way of taking that municipal wastewater, rather than turning it into drinking water or putting it into the aquifer, actually using it in some industrial application. And then, you know, the state, California is a huge oil and gas producing state, right? So there's opportunities there. And on the right-hand side, you can see one of our pieces of equipment. Again, we're doing some aeration, like I mentioned, around the winery wastewater. We're doing aeration of some of these lagoons that are created from the oil and gas industry. And you can see a little rendering on the left-hand side of how that works, where we're using Venturis to put air bubbles into the lagoon on the bottom side, and then circulating it, as I showed before, with the with that computational fluid dynamic modeling system.
Very cool. Very interesting technology, that's for sure.
Yeah, and so looking to the future, some opportunities. You know, flood waters, stormwater. That's going to be a huge thing. I mean, we have to look at where we can supply water, but you're also going to have to treat that water, right, before it goes into not necessarily a dam or a reservoir. But if you're going to look at it, storing it down in an aquifer, you really need to treat it beforehand so that it doesn't build up any biological contamination underneath. And then as I talked about with the East Bay Mud and Chevron Richmond refinery, these server farms, these computer server farms, which are storing all the data centers, they need a lot of cooling water. I mean, you're moving electrons, you're generating a lot of heat. So you need to cool that. And so what's being looked at is, can you co-locate these server farms near wastewater facilities? So you treat the wastewater. Again, you don't have to get it to drinking water. You have to, number one, get rid of any pathogens because you don't want to expose people to that. And then you also have to get rid of any problematic organics that or scaling that might cause problems with the cooling systems in these data centers. But it's something that's been started, and it's getting more and more of traction as people are looking at reducing the amount of drinking water to use to cool these server farms.
That's cool because it really solves two problems. One, right, we don't have to treat all water to drinking water standards to be used. And two, we spend so much of our energy, California, 30%, close to 30% of our energy just to move water. So let's move these things closer to where the water is. We'll save, it'll be a double save.
Exactly. So this is a question I've always asked, I've always heard this region is the Silicon Valley of water. Israel's been in Singapore, Milwaukee. I mean, I've heard, and for me, I mean, we talked a lot about the hardware that's being used in water treatment, but there's a lot of software that's good. We showed some of the computational fluid dynamic modeling. There's a lot of things that need to be done around the software. And so, one of my favorite topics is Leonardo da Vinci. He always looked at the world, the human as a microcosm of the world. And, for me, I look at a water treatment system kind of like that, right? So you got part as a pump. We've got these efficient pumps now, VFDs and so on, the circulatory system, piping and so on. We've got kidneys. We got filtration systems that work like kidneys. We've got the immune system that works like disinfection systems, sanitizing systems. And then, we've got optical sensors that can see turbidity. We've got acoustical sensors that can hear leaks, pH sensors, taste, if you will, base and acid. But the weak link to me in controlling all this is the brain, right? And so really there's opportunities around improving SCADA systems in municipal applications, what we're doing in the fields and ag, right, irrigation, and how we're measuring soil moisture and tapping that into satellite imaging. And so the brain is really where we've got some of the most opportunities to be more efficient. And so, Silicon Valley and their software capabilities, ag tech, that's going to be a big part of what I see in the future. And, tech needs water, water needs tech, right? We talked about the cooling water. We talk about the fact that we want to control these systems more efficiently. We talk about desal, right? So we talked about the technical advances in membranes, but also, we've got better energy recovering devices that work feed-forward feedback loops. We've got the knowledge that, when to turn it on, when to turn it off. So tech is going to be a really big application. So I guess, at the end of the day, there's new hardware and there's new software to solve water and wastewater problems. And I think here in California, we're very well situated for these opportunities. And if you look at it, whether it's technologies, learning from other regions, we talked about, and market sectors, there's really no silver bullet. So we started with gold and we ended with silver. Yeah. And the point is, whether you're a big company, a small company, whether you're software, hardware, if you're in the water space, you probably have some solution for one of the sectors that California is facing and some of the challenges it looks at as far as water is concerned.
Yeah, I'll tell you what's really exciting about that, Jim, is a couple things. One, we do have the technology. We can beat this water challenge we're experiencing with technology and with people. So that's really great news. And then the other thing, when I look at products like Jane Unity or Jane Logic from Jane Irrigation. I think this is really fun to work in and build and be a part of. So it's not just we're saving a water challenge. We're also creating some really cool jobs and some really interesting ways for people to improve the society in which they live.
Exactly. It's exciting. There's money to be made, right? The gold. But there's also the feeling that, you know, we're contributing to society and we're really achieving something for our state and for the rest of the world. So absolutely. So, you know, please connect with me on LinkedIn. Like Richard said at the beginning of the webinar, I'm very active. I write a lot about sustainability, a lot about water issues, and love to connect with you.
Yeah. So, Jim, thank you so much. What a great education we got this afternoon. Lots of very interesting information. Really appreciate you sharing all that with us. To all of you that tuned in today, I want to say thank you. I know everybody's got busy days these days, so I appreciate you spending a little bit of your day with us. Please remember, all of our trainings are at the janesusa.com/trainings page. You can also listen to any of our webinars as a podcast as well. We extract this audio out, put it up as a podcast, and I just love it to think people are out there working and educating at the same time. It really gets me excited about what we do. So thank you, everybody. So Jim, thanks again. We really appreciate it. And we'll see everybody next week. We're going to be talking about some new water reports that are being generated on a daily basis that will be helpful to all water managers. So look for that. Again, Jim, thank you. Really appreciate it.
Bye now.